Good afternoon. Welcome to Internet Scale Analysis of AWS Cognito Security in Mandalay Bay, Room Lagoon JKL with Andres Riancho. Before we begin, I have a few brief notes. Stop by the business hall located in Mandalay Bay, Oceanside, and Shoreline ballrooms on level 2 during the day, and the welcome reception at 5:30 p.m. tonight. The Black Hat Arsenal is in the business hall on level 2. Join us for the Pony Awards in Lagoon JKL at 6:30 p.m. It is in this room, and thank you for putting your phones on vibrate. Andres?
Thank you so much. Hi, everybody. Good afternoon. Today, I'm going to be talking about an internet scale analysis of AWS Cognito. First, we are going to start with patient 0, the first vulnerability that I found. And then we're going to extend it to internet scale. So I was performing a cloud security assessment on one of my customers. And as part of that assessment, I got read-only credentials for their AWS account. Using those credentials, I enumerated all of the permissions, all of the services that were in use by that account. In that list, and as you know, AWS has a lot of services. In that list, something caught my eye: Cognito. I never seen that before, and it's not a very common service. So that's the logo for Cognito. I had no idea what it was, so I went to the documentation, like any good hacker. And the documentation showed me something beautiful, one line that made my day. That line said, identity pools, which are a component of Cognito, enable you, the developer, to grant your users access to AWS services. So the developer grants end users access to S3 buckets, DynamoDB tables, and almost any other resource in the AWS account. What could go wrong? So during this assessment, I was able to gain full access to the AWS account, exploiting Cognito misconfigurations. And I'm going to first explain how I did it, and then we're going to try to automate that process. The first thing that I did was to use my read-only credentials to extract the identity pool ID, which is what you see there in red, from the AWS console. I extracted the ID, and I used it in this function. This function is going to take an identity pool ID and return AWS credentials, because that's how Cognito works. It's going to give end users AWS credentials with some associated permissions. From now on, for you guys, this is just a black box. You enter identity pool ID, and you get credentials. The next steps that I took in order to own that AWS account were to enumerate permissions, because I had credentials, but I had no idea which actions I could take with those credentials. So I enumerated permissions and then used different privilege escalation techniques to gain access, to elevate privileges and gain access to the AWS account. That was great. My customer was happy, I was happy, and I learned a lot in the process. And I finished my report, and I was asking myself, all right, I got one. I was able to exploit one misconfiguration in AWS Cognito. Are there any other? So this is what kickstarted my research. How many customers were at risk? How common is this? How many developers are misconfiguring AWS Cognito. And is it possible to actually measure this and answer the questions that I'm making myself? Of course, I'm here, so yeah, it's possible. This is what's next. I'm going to try to explain in 5 minutes Cognito and how it can be misconfigured. Then I'm going to show you how to grab the internet, which is great. Then I'm going to show you results for this analysis and perform root cause analysis. Try to understand why this happens. Introduction to AWS Cognito. Basically, there are two main components: user pools and identity pools. User pools store all the users. It's a directory. Identity pools provide AWS credentials for authenticated users. In that graph, you can see how the mobile application talks first to the user pool and authenticates in some way, then talks to the identity pool in order to get AWS credentials, and finally, the mobile application consumes AWS services, S3, DynamoDB, Lambda functions, whatever. In order to understand this, it's easier if we get a use case. Let's imagine a sample application. This application is just cool cat pics. It allows users to upload pictures of their cats, because cats are cool. And this sample application allows users to directly upload to S3 all of the images. And also, the metadata, like the name of your cat, goes to DynamoDB tables. So there's no server in between. The mobile application is directly consuming AWS services, writing to S3, writing to DynamoDB tables, and all of this is possible because of Cognito. Also, this application uses Cognito for authentication. There's something special about this application. There are two different user roles. Authenticated users can upload new pictures. Unauthenticated users can only read pictures that were previously uploaded. So remember that, authenticated and unauthenticated. And they have different permissions. All of this is done using the AWS SDK, which is available for Android and for iOS. Those SDKs are used to consume the APIs and to make the life of the developers easier. If you want to have the same application in your browser, that's totally possible. And in order to do that, you need to use the JavaScript SDK. In that case, instead of a mobile application consuming APIs from Amazon, you have your browser running JavaScript consuming those APIs in a direct way. When a developer is creating a new identity pool, this is what he sees. He's going to see a form with 3 inputs. The identity pool name, that's easy. An authentication provider, he needs to choose how he's going to authenticate users, Facebook, Google, whatever. And then something that's going to be interesting for us. Unauthenticated identities. Is this identity pool going to have support for unauthenticated identities? So users that never go through the authentication provider can still get AWS credentials. Once the developer finishes that form, the next step is here, and he needs to assign IAM roles to Cognito identities. IAM roles are like users, to summarize, are like users in AWS. So a role has permissions. And the developer needs to assign different permissions for the authenticated identity and for the unauthenticated identity. Permissions in AWS are defined like this, with policies. In this policy, we see how we are allowing S3 list bucket on a specific bucket name and S3 star object on that same bucket. So the developer needs to create a policy to restrict the permissions for each of those identities, the authenticated one and the unauthenticated one. Once he does that, we get the final screen where we see, as developers, the identity pool ID. It's ready to use. It's 100% configured. All good. So something to notice before I go to internet scale is that these IDs are randomly generated. I'm talking about the IDs that are in red in that screenshot. Those IDs are unique IDs. They're randomly generated. It's impossible for me as an attacker to guess one of those IDs. I need to extract them from somewhere. All right. Now, internet scale. How I took all of this knowledge to analyze the internet. So this code snippet shows what I did. And of course, I have a function there that says get identity pools from the internet. That doesn't sound very doable, but bear with me for a minute. So for each of the identity pools that we get from the internet, I'm going to get the credentials using the function that we saw before in one of the first slides. Then enumerate the permissions for those credentials. And in some way, we want to score those permissions. We want to know if they are good, bad, insecure, or secure. And with all of that information, we want to do pretty graphs and go to a conference. So, first challenge. Identity pool IDs are randomly generated. I can't simply guess them. They are too long. They are randomly generated. So I need to extract them from somewhere. And that somewhere was mainly the Google Play Store, but also some other resources, like the Common Crawl, GitHub, and so on. My first approach was to download all of the applications from Google Play, decompile them, and extract identity pool IDs from those files using grep. That doesn't work. Google Play has 2.6 million applications, and that's a lot. And they have protections against automating downloading of all of the applications. So it's not easy, at least I had a week for this research. So it's not easy to automate the whole process in just a week, or download 2.6 million applications. So I had to use something different. What I was really interested in was the mobile applications that use the AWS SDK. So I found a service provider that allowed me to filter by those applications. That service provider allows you to search through all of the applications in the Google Play Store and gives you a result of the ones that use the libraries that you want. With that, I got 13,000 applications and downloaded the applications from alternative sources, APK Pure and APK Mirror. Those don't have as many limitations and controls as the Google Play Store. So I got all of those applications. I was able to extract a lot of identity pools, and I was ready to, based on that information, get credentials. Then I moved into the internet, because if you remember from my use case, the Cognito service can be consumed by mobile applications and by JavaScript applications running in browsers. So I was wondering how many web applications were using Cognito. And in order to do that, I started to Google. And I tried to Google for Cognito identity credentials. The thing is that Google doesn't index the contents of script tags. And it will not index attributes like the ones that we see in the first part here that says Amazon Cognito identity.min.js. So if you search for that, you're not going to find sites that use it. You're going to find blog posts that mention how to create sites with Cognito. So I really needed a way to grab the internet. I needed a way to do exactly that, like grab some directory where the whole internet was. And we all know that that doesn't exist. But yeah, actually it exists. So Common Crawl is an open repository of web crawl data. Common Crawl stores 2.5 billion web pages. They crawl the internet, and they store it for you to analyze. It's free. You can access this information, this data set, for free. And that's what I used. Instead of grabbing the internet, I grabbed Common Crawl. Common Crawl has 2.5 billion web pages. That's more than enough for my research. I tried first with existing tools. There's one called CCMRjob, which uses Elastic MapReduce in order to process the contents of Common Crawl. But that had some stability issues. The error handling was really bad, so I had to create my own. I created something called CC Lambda, Common Crawl Lambda, that uses AWS Lambda to apply regular expressions to the Common Crawl. CC Lambda implements that grep that we are seeing there. It uses 1,000 concurrent AWS Lambda functions running at the same time, which are like a lot of processing power, to download a piece of the Common Crawl, extract, like unzip it, and then apply regular expressions to all of the 2.5 billion pages. All of the results are stored on S3 for you to investigate them. This is how CC Lambda looks like. It's simply, you need to code your own function in order to apply your regular expressions. And it will extract the info and store it on S3. For each of the chunks of information from Common Crawl, it will take around 3 minutes. It's expensive. I invested around 300 USD to run CC Lambda on Common Crawl. Maybe if I use a little bit of performance enhancements, I would be able to cut that in half, but it would still be expensive. So if you use it, don't blame me. I told you, it's expensive. Other borrowing sources for identity pools, GitHub, Shodan, and some others. I just consume the API and extract the information. So there's nothing new there. So at this point, I extracted identity pool IDs from the Google Play Store, from the internet, and I have all of those identity pools ready to be used. Once I got the credentials from those identity pools, I had to enumerate the permissions. I had simply like API keys and no idea what they were capable of. And I wanted to enumerate permissions with some restrictions. There are two ways to enumerate permissions in AWS. One is using the IAM service. The other one is using brute force. When you have a set of credentials in AWS, you can call the IAM API, and it will tell you which permissions you have. But in order to do that, you need permissions for IAM. And in this research, none of the credentials that I got had permissions for IAM. So I had to do brute force. I had to call each and every AWS API, and if the response was forbidden, I had no permission. If the response was, okay, this is a list of resources, then I had that permission. Simple brute force. The problem here is that you just want to test for read-only APIs. If I would try to call an API that's going to terminate an EC2 instance, just to see if it's possible to do it, if it works, I'm breaking somebody's cloud. And that's no good. So I had to just enumerate the read-only permissions. And from that set, I had to choose a subset for only the API calls that returned infrastructure metadata, not the ones that returned customer information. Let me give you an example there. Infrastructure metadata is list the names of all the buckets in this account. Customer information is give me one file that is stored on S3. I didn't want to read customer information. I wanted to read just the names of the buckets. And all of this is, of course, to avoid going to jail, right? Nobody wants that. So performance, I had to do a lot of API calls, and the existing tools were pretty bad at performance. They use a single thread. They were testing just a subset of the API calls that I wanted to test, and actually I wanted to test all of the read-only ones. Tried different tools, didn't like any of those, so I created my own. Do you see a pattern here? I try something, I don't like it, I create my own, like every time. I wrote a tool, it's open source. CC Lambda, it's also open source. Enumerate IAM, it uses threads, it's written in Python. It allows you to enumerate permissions for a set of AWS credentials. It looks like this. You provide the credentials, and it will output the different API calls that you can actually perform. All right, statistics. At this point, I had a lot of identity pool IDs, credentials for each of those identity pool IDs, and a list of permissions associated with each of those credentials. And I wanted to know if there was a pattern somewhere. Before we go deep into the result analysis, let me explain something here. The privileges that I enumerated are only for the unauthenticated role in Cognito. I did not perform any type of analysis on the authenticated role. Something else to notice, and this is kind of common sense, the privileges for the unauthenticated role are going to be smaller than the ones associated with the authenticated role. So all of the results that we are going to see now would be much worse if I would have done it with the authenticated role. Most applications that I inspected allow users to sign in, create a user in the application, and gain access to the authenticated role. So it's just one more step. I'm lazy, I didn't do it. So, identity pool sources. I was able to, with the different methods, get access to a list of 3,100 identity pool IDs. Those IDs are distributed like that. The great majority came from the Play Store. Then a few came from GitHub, Common Crawl, Yandex, and so on. But those identity pools are not all usable. Some of them didn't exist. At some point, they existed. Someone created a mobile application. They used it. Then the mobile application failed. They tear down the AWS account associated with the mobile application. They simply don't exist anymore. Others, 300, around 300, only allow authenticated roles. They don't allow unauthenticated roles. And I checked for that. And some others, around 100, had an invalid configuration. At one point, they, for example, removed the IAM role associated with the authenticated or the unauthenticated identity in Cognito, so they broke the Cognito configuration. So at the end, this research is based on 2,500 identity pools, which is quite a good number to come to conclusions. Something that I really struggled with was, how do I tag a permission set as secure or insecure? Each application has its own set of requirements. Each application needs a different set of permissions. So just one permission here being enabled doesn't really need to be insecure in the other application, and the other way around. But I was able to identify some API calls that, in my opinion, are always an indicator of insecure configurations. So let me show you which API calls those are. First, S3 list buckets. In 1 out of 5 identity pools, I was able to run S3 list buckets. And let's analyze why that's bad. When we are in a mobile application, in the sample application that we were analyzing before, the mobile application knows where to upload the picture. The mobile application knows the name of the bucket where it will upload the picture. It doesn't need to list buckets. It can just upload it. The same happens with, for example, Lambda list functions. The mobile application knows the function name to call, and it just calls it. It doesn't need to list the existing functions. And maybe it's a little bit clearer with Dynamo.list backups. Why does a mobile application need to list backups for a database engine? So this is a good and strong indicator of misconfiguration, of a developer granting more permissions than the ones needed by the web application or the mobile application. So 1 out of 5 developers are misconfiguring their Cognito identity pools. Something else that I tried to do was to identify if an attacker exploiting this vulnerability would have access to sensitive information. And just as a reminder, I did not read the contents of S3 buckets. And I did not read the contents of DynamoDB tables. But when you perform S3 list buckets, you get the bucket names. And if the bucket name contains the word secret, password, credit card, backup, then, all right, you're screwed, and that goes into the red part there of my graph. It's sensitive information. And I was able to gain access to 900 S3 buckets with sensitive information using all of these techniques. In total, I was able to get access to around 13,000 S3 buckets, which are not public. They are just accessible if you have AWS credentials for that account. They are not public. They are just owned through AWS Cognito. Something very similar happens with DynamoDB. If the table name contains password or credit card, then it's a sensitive, it contains sensitive information. And I was able to gain access to 37 databases with sensitive information. And the total was 1,100. So through these techniques, I was able to gain access to a lot of information. This information stores this database store customer information. Something interesting is that when you list Lambda functions, you don't only get the function name, you also get the metadata associated with that function. Included in that metadata, you find the environment variables which are used to run that function. And usually, developers store secrets in those environment variables. So by running lambda.list functions, I got access to around 80 secrets, like API keys, database connection strings, other AWS credentials, and some other stuff. All right. Root cause analysis. When I started with this research, and before going internet scale, I contacted AWS Security just to let them know that I was going to do it. And through the whole research, they were very supportive of the whole process, and they helped me understand a few things about Cognito, and also helped me understand what they were going to do to fix it. My understanding of this is that the root cause for this issue is twofold. We have insecure by default documentation, and we have some issues in the UI. Let's start with the insecure by default documentation. At least before I reported it, there was an example in the official AWS documentation, which is the source for every developer to use for writing a new application that uses AWS Cognito. There was an example there which granted overly permissive policies to unauthenticated roles. So developers that were just starting with this copy-pasted from there and created vulnerable Cognito applications. When I reported this, they added a note, and okay, the note is enough, I believe. We'll see. Something else is that, and this is kind of okay, there are some restrictions to the permissions that a developer can assign to an unauthenticated role. So a developer can assign permissions for that unauthenticated role in Cognito with only 26 services. That's why IAM doesn't work. That's why I didn't find any credentials that had the IAM service enabled. So this is good. There's at least some restriction for the unauthenticated role. But still, I was able to gain access to a lot of S3 buckets, to a lot of DynamoDB tables. I was able to gain access to Lambda functions, the source code of Lambda functions, and a lot of information stored there. There's no restriction for authenticated Cognito roles. So if you're a developer, you can assign any permission to that authenticated role. So AWS is allowing the developer to shoot himself in the foot. By not performing enough checks, it's allowing developers to misconfigure AWS Cognito. I get it. It's the developer's responsibility. It's on the developer's side of the shared responsibility model. It's not 100% AWS issue, but they are not helping enough. That's my understanding. For developers, you guys watching on YouTube and any other developer here, use least privilege principle. Always, for anything you do, and specifically for Cognito. Least privilege principle means only give the required permissions for the application to work. Only assign those permissions, nothing else. If your IAM policy has a star somewhere, you're doing it wrong. And something that we didn't talk about during this session is object-level permissions. If we have a DynamoDB table that holds information for different users, maybe user A should only be able to read his rows in that table, and not the rows from user B. That's something that I did not explore during this research, and it's also really important for developers when they create their applications. All right, bonus. When I was doing CC Lambda on the internet, I said, why not search for hard-coded credentials? People tend to do that. So I did. And I found 280 hard-coded credentials. And I'm not sure why, but almost 10% of those were root accounts. With root accounts, you can destroy the account. You can close the account. You can do whatever you want. And from those 280, 38 had elevated privileges. I could do almost everything. They were not root accounts, but I could do almost everything. Those credentials were hard-coded somewhere on the internet, and I found from the 26 that were root accounts, 25 came from command crawl. So if you want to do some evil, go to command crawl, grab there, find root accounts, do some Bitcoin mining. And of course, I reported everything to the AWS security team. I'm pretty sure some of you guys are here. Closing thoughts. So there are three important things that I want you to take away from this session. First, AWS Cognito is commonly misconfigured. Developers are assigning excessive privileges for those roles. If you are ever doing an assessment and you find AWS Cognito, check it out. Learn, exploit, and gain access to sensitive information. If you don't do it during your assessment, an attacker is going to do it. Use CC Lambda to grab the internet. There's a lot of research which can be triggered by this. Just searching the internet in different ways can give you a lot of information for evil or for good. And use Enumerate IAM in order to enumerate permissions when you get access to a set of AWS credentials. And of course, follow me on Twitter. I'm doing a lot of cloud security research, and I post everything there. If you want to continue with this research, you can extract identity pools from iOS applications. I didn't explore anything related with iOS. Maybe there are similar services in other cloud providers. I only focused on AWS Cognito. There might be others. The easiest thing for you guys to do if you want to continue this research is authenticated role analysis. I only focused on unauthenticated role analysis. You could extend this research and see where it goes, where it leads. And finally, and I don't recommend this, but maybe you guys want to do it, privilege escalation analysis. Is it possible for those credentials to be used to escalate privileges in the AWS account? That's what I did during my cloud security assessment, because my customer was okay with it. I would recommend you not to do it on random AWS accounts on the internet. It could be seen as an attack, because it is. And I'm not going to do anything related with this, so it's all yours. I'm here if you want to ask me any questions about continuing with this research. So that's it. Any questions? And there are a few microphones there if you want to ask questions. If not, and you want to ask questions in private, I will go to the room in Reef A, I believe. There's a question there? Yeah.
Andres, thanks for the nice talk. So a question about this over-provisioning of privileges. So what's your experience with Amazon's reaction to that? So I did some work for iOS and Android in 2013 or so. We saw that effect. 3-4 years later, it was still published that privileges are over lenient. So how's Amazon reacting to what you found?
At least in my case, they were very good during the whole process at communicating and explaining that it was not their fault. It's on the other side of the shared responsibility model, and I get it, but that shared responsibility model, in my opinion, it's not a straight line. It's a gray line. It falls in between.
But to that end, I'm not too familiar. So for example, if you would go and publish an app in either iOS or Android market, they have some background security
Yes.
verification, which is not too strong.
But
So
that's
with
for
Amazon
hard-coded
doing that,
credentials.
Uh-huh.
That's for hard-coded credentials in mobile applications. That does not apply to Cognito identity pools.
I know, but is Amazon trying anything like that? At least the best effort, or no?
I don't think so, no.
Okay, thank you.
You're welcome. Any other questions?
Thank you.
No? All right, thank you.